Everyone. So I'm Sankalp there, a final year student at VIT Vellore, and I was not able to upload videos in the last few months because I had my internship and last month we had placement, so I was busy with them. And now I'll be uploading videos like daily, and I've also decided to upload videos category wise. So, for example, I'll be uploading dynamic programming videos in 1 week, arrays video in 1 week, and then stacks you like all the topics weekly. So for the first week, that is this week, I'll be doing the dynamic questions, DP questions. So this is the first question that I've selected. So the question is, see, unique paths, and the question is as a robot is located at the top left corner of a M cross N grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, and we have to find how many possible unique paths are there. So as in the given figure we can see this is a 3 cross 7 matrix, and we are at the 0 0 position and we have to reach 2 comma 6 if we use 0 indexing. So in this we can also use DP to solve this question. So what we can do is we can create a DP of this size, that is 3 cross 7, and then we can initialize all the initial values with 0 or 1, whatever is necessary. So for example, if we are at the 0 0 position, it will be 0 because we don't have any unique path there. And for the first row we will have only one unique path, that is if we go directly to the right always. And for the first column we will have only one path because if we go always vertically down. So this is for the first row and the first column, and for the remaining the cells we can calculate the values based on the based on the value that is above and on the left. So for example, if we are at 1 comma 1, we can take the sum of 0 comma 1 and 1 comma 0. So these are the possibilities through which we can reach 1 comma 1. So in the given example 1, we have m is equal to 3 and n is equal to 2. So we will initialize the matrix with 0, and then we will initialize the first row with 1, and for this value that is at 1 comma 1, we can move to this position from above position or the left position, that is we can move down from 0 comma 1 and we can move right from 1 comma 0. So this will be the sum of 1 and 1, that is 2. Now for the position 1 comma 2, we can move to this position either from 0 comma 2 or from 1 comma 1. So this is the sum of both of them, that is 1 plus 2, which will be 3. So the final answer will be the last value, which is 3, and here also we can see that it is 3. So now we can code for this, and we will also check if m is either less than 0 or n is less than 0. We will return 0, and now we will create the DP array, that is n columns and m rows. So this is m cross n, and now I will assign all the values in the first row. So here n is the number of columns, now DP of 0th row and ith column will be 1, and same thing we will do for the first column. So here m is the number of rows and DP of I comma 0 will be 1. Now for the remaining cases we will take we can use row and column to make it look better and understandable. So now this dp of row and column will be equal to the sum of the previous row, and it will start from 1, not from 0. So both of them will start from 1, and it will be row minus 1 and column, and dp of row and column minus 1. So this will be the values, and finally we will return. Okay. Okay, so now this is submitted, and for this solution, if we see the time and space complexity, now in this case we can see that we have this one for loop which is of big O of n time. This is another for loop which is of big O of m time, and here we have nested for loops, that is big O of m cross big O of n, that is big O of mn time, and all and other than these we don't have any linear time or even more than that. So the overall time complexity will be for this one, that is mn. So this will be big O of mn, and for the space complexity we have this dp variable which is a 2D matrix of size m cross n. So the overall size will also be m cross n. Now this question is solved, and this is good for coding rounds, but during interviews if we give this solution we can be asked to optimize it, and if we try to see this question, we can see that it is just a combination of some writes and some downs. So for example in this first case we have total of 3 values, that is 2 write and 1 down. So we have to just find all the combinations of them. So we can do this using some formula in maths which is combination. Now if we see, we have a total of m plus n minus 2 times 2 steps, that is m plus n minus 2. These are the number of steps, and the number of either right or down. If we see the number of downs, it will be m minus 1. That is, these many times we have to go down to reach the final position, because we can't go up or left. Now if we try to use this, we can find NC. We can use this NCR formula. Here n is equal to the number of steps and r is equal to the number of downs. Now we can also solve this using a for loop. So this NCR is m plus n minus 2 factorial divided by m minus 1 factorial into m plus n minus 2 minus m plus 1 factorial. And if we try to write this using steps, so this is steps factorial divided by steps minus down factorial into down factorial. So if we just remove all the common parts from the numerator and denominator, it will be steps minus down plus 1 multiplied by steps minus down plus 2 into dot dot dot. It will be up 2 steps. So this will be the numerator, and denominator we will have down factorial. So we can use this d as down, so it will be from 1 to down plus 1. So when it is 1, it will be this form, steps minus down plus 1. Here d is 1, and for d will be, and when d will be down, it will be steps minus down plus down, so down and down will be 0, and it will be steps. So this is the entire numerator, and for denominator it will be d. So it will be, so we can use result. This will be the multiplication of steps minus down plus d divided by d, and then finally we will return the result. Okay, so this was the second method. Okay, so this was the solution using this combination method. You can use it as res into. Okay, and now we can run it and submit the code. Okay, now if we try to analyze the time and space complexity for this method, now the time is, now here we have only one for loop which is running from I to down, and down is equal to m. It is of the order of m. So the overall time complexity will be big O of m plus n, that is maximum of m or n. So whichever will be maximum, that will be taken. Because we can have 2 and 3 also as the input instead of 3 and 2. And for the space complexity, we will have only 2 variables here. We have, that is steps down and find the final result. So we don't have any array for storing the variables, like array variables we don't have. So the overall space complexity will be constant. So this was the solution for this problem, and in case if we are not able to solve this question at the first attempt, so we can always try to get some hints from the discussion section. So if we open this discussion section, we can see all the posts that are created by other people. Then we can sort it by most votes, and then we can look at some of the best solutions that are given. So if we open the first 3 links which I have already opened, we can see that they have also used 2 for loops initially and a 2D vector for storing the values, And then so they have always used this variable of linear space. If we see another solution, here we can see that they have used the formula that is the same as we did, that is combination of n comma k. So this is more efficient than the previous method. And then another method we have, so this is also based on the formula. So this will also have linear time and constant space, so which he has written as constant space. So in this way also we can look at the solutions if we are not able to do it on our own. And thank you for watching the video. Do like, comment, share and subscribe the channel if you like the video. And for the next week, for the next videos, we'll be doing this question, that is unique paths part 2, in which we will have obstacles in between and we have to find the total number of unique paths that are present in the given question. So that's all for this video, and see you with the next video. Bye. Thank you.